Let me just start this video by saying that if you don't remember your Laplace transforms, you're going to have a bad time. You absolutely 100% need to know these things inside out and backwards to do the inverse Laplace transform, which is the forwards Laplace transform backwards. For general strategies, first thing you want to do is look for capital F at S, which is all of these things. This is why you need to remember them. You need to be able to spot them in your equation and know to go back to these ones. If you have some sort of quadratic equation on your denominator, first thing you want to do is complete the square. If that doesn't work, partial fractions. If that doesn't work, you need to remember your Laplace rules, and we'll do an example in these so you can see what I'm on about. So the first one here, we're going to take the inverse Laplace transform of s over s squared plus 6s plus 10. So the first thing we're going to do, we're going to complete the square because we have quadratic here. So to do that, you get s over s plus 3 squared plus 1. And we're going to notice here that this kind of looks like the inverse Laplace, sorry, the forwards Laplace of cosine, which is s over s squared plus b squared. But we have s on the top and s plus 3 on the bottom. We need them to be the same. So we're going to add 3 and subtract 3 to keep it the same. And then we're just going to split those up. So we have our s plus 3 here. And on this side, the 3 just comes out front and you have a 1 on top. So using your Laplace rules, of course, this is the same as this one. So we have the cosine of t. And remember our s minus a rule. So we have e to the at. In this case, it's negative 3 is our a because it's s minus a. So s minus negative 3 plus 3. And then minus the 3 just comes out front there. Same thing here, except we have the sine of t there. This one here, you have the inverse Laplace transform of s over s squared plus 1 all squared. So we don't have a quadratic. We can't use those other two rules. So first thing we're going to do, we're going to notice here that the derivative of 1 over s squared plus 1 is this, which is very, very similar to what we have. So if you're unsure of what to do, you can try taking derivatives of, see, this is just the sine Laplace transform there. So you can take derivatives and you get something similar. You can use this formula here, which we learned when we did Laplace transforms. Okay, so the way this works is I've taken the formula and I've just taken the inverse Laplace transform on both sides to get it into the form that we can use. And we can see we need here a derivative of some function. We have a derivative here, but we're not quite the same. We're off by a factor of negative 1/2. So we've taken the derivative of this and just put that negative 1/2 in there so that we are in fact kosher with this one here. Now we can just simply follow out what this formula says. So it equals, we have this here is this here. So we have equals negative 1 to the power of n. In this case, we have only one derivative, so it's our n is 1 times t to the 1 times f at t, which is the Laplace transform of this. Sorry, the inverse Laplace transform of this. In this case, it's the sine of t, and our 1/2 comes in there as well. Important thing to notice, we're not moving the 1/2 over. This is a continuous equation. We've stuck a 1/2 in on this side, so we're going to stick it in there in the same fashion. So don't move that over and put a 2 there. This is a negative 1/2. And we just reduce that down. We get t sine t over 2. And if you wanted to, you could take the Laplace transform of that just to double check your work, and you will get that one. Math isn't so hard when you have the right tutor. Be sure to check out the description for links to other courses and topics. Also remember to tell your friends about the TheKFully channel.